Good morning, everyone. This is Mike Heitzman. I am going to be the moderator for today's session. This is a roundtable on agency and industry GPR experience using pavements or within pavements. The purpose of this roundtable is to discuss the use of GPR for pavements. Pavement applications could include preparation for a rehabilitation project, construction quality assurance, forensic investigations, and condition surveys for asset management. Today's information exchange should be helpful to every agency and consultant. Learn to avoid others' mistakes, not to reinvent the wheel, and to improve your GPR implementation program. The format of the roundtable is a 40-minute panel discussion where I, as the moderator, will pose questions to the panel members and they will respond and discuss their positions. And the last 20 minutes of the roundtable will be audience participation through written questions and comments. Since we have well over 400 registered for this webinar, I'm sure I will not be able to respond to all the questions within the time allotted. So we will select a variety of questions. And after the roundtable, we will attempt to respond by email to any questions that are not discussed during the roundtable. To ask a question, please enter that question into the Q&A block at the bottom of the screen. Please do not use the chat block for your questions. During the roundtable, the audience will be asked to respond to several questions. The results of this will give us a better understanding of what is the status of GPR for use in pavements. And with that, here is the first question. How much GPR experience do you have? And Kent will show the questions there for you to respond to. While Kent's getting that up, I'm going to ask the panel members to introduce themselves. And we're going to start with Bill in Caltrans.
Right. Good morning, Mike. This is Bill Owen. I'm with California Department of Transportation, Chief of the Geophysics and Geology branch. We have about 24 years of experience working with ground penetrating radar systems in various capacities. And we do work for the entire state highway transportation network.
Kyle.
Hi, everyone. I'm Kyle Hoig. I'm a research engineer for Minnesota Department of Transportation. Been working with GPR for about 15 years now. And I guess the focus of a lot of my discussion here today will be for use on new construction with a density profiling system.
Thank you. Eob.
Good morning, Mike. Good morning, everyone. My name is Eob Zageye. I'm a pavement research engineer at MnDOT. I currently lead the MnDOT's Road Doctor program, which was created 5 years ago now, specifically to evaluate and explore application for innovative technologies like the 3D GPR and others. And I'm also the project manager for the recently activated pool fund study on stripping and GPR, and we're trying to work with the state members and vendors like yourself and others, subject expert matters to advance the use of GPR to detect automatically stripping and other subsurface defects. So I've been working with GPR for the last 10 years between MnDOT and other consulting services. Thank you for having me here.
Thank you. Jacopo.
Yes, hello everybody. I'm Jacopo Sala. I'm currently chief scientist for Kontur. I'm very happy to be here today and together with a lot of smart people. Hope to be at a decent level. But my role in 3D radar, or now Kontur, before 3D radar, is mainly to design algorithms and find ways to apply a GPR system to realities and applications like asphalt and pavement. So all in all, I started 3D radar before Kontur. Kontur is last year we changed. 3D radar is started in 2008. And the total experience with GPR is about 20 years now. So, and I touch a little bit of this and that. So it's not only pavement, what is in my background.
Thank you. And Bryce?
Yes, thank you, Mike. Happy to be here. I'm with GSSI. I'm the transportation manager and asphalt specialist. I've been in the asphalt industry for a little over 17 years now, working with all kinds of different technologies. My experience with ground penetrating radar has been about 6 years, mostly using it as a proactive tool in construction, as a QC tool. We also have been doing analysis, forensic, pavement analysis, and use those tools as well to efficiently look at conditions of sections and make decisions. So happy to be here and glad we could all get together.
Great, thank you. For the audience, we did have one other panel member originally planned, and that was Hoda Azari with FHWA. And she has been called away to a more important meeting, I think, at the White House, I understand. So we gave her permission to not attend and participate in this roundtable. So with that, let's go ahead and begin. I'm going to pose the first question to the agency panel members. Do you market your GPR services to the pavement practitioners, those being project designers or maintenance or asset management? And if yes, how do you do that? Anyone want to start?
I can start. Kyle Hoig from Minnesota Department of Transportation. I guess a couple things I would mention is that I'm not looking at marketing from a sales point of view in my position as a research engineer. It's more of a marketing, two things. One, the trust level between what we're researching and what we're giving as guidance from the research group to decision makers, as well as technical marketing. These are the current capabilities of the technology itself. So the focus for me personally, as it relates to marketing GPR services, is to try to allow the district engineers and other decision makers within our office, whether it's specialty office or other personnel and even contractors, what can we use the GPR technology for, and what are some of the current limitations so they can make well-informed decisions.
Great, thank you. Bill, anything to add?
Sure. We do direct outreach to our project engineers and to our geo professionals who are responsible for maintenance and project design. So we act essentially as an internal consultant within the department. So our marketing, if you will, it consists of training, outreach. We have an online presence on our intranet site, and GPR is one of the tools that we use in our day-to-day applications. And so with turnover and with development of new processes and new techniques, we're constantly doing outreach and training and essentially talking to people on both an individual and a group basis to show them, here's who we are, here's what we do, and here's what we can bring to your project.
Great, thank you.
Mike, if I can add
Yes, go
one thing
ahead.
to that, I think one thing that has been helpful for us that we do is we do have monthly user meeting where we bring out all the specialty offices like pavement design, pavement maintenance, district engineers, and basically we share with them about the capabilities of these technologies. Basically, the idea is to build confidence on these technologies, and we hear from them their particular needs. And once we have, when we learn about their needs, we try to somehow fine-tune the testing and reporting of this technology to their particular needs. And having this monthly meeting with them, we found it very useful. So,
great, thank you. Let's move on to the second question. Since we are talking about pavements today, I do want to ask that broader question, and that is, do you market the GPR service to other departments in the agency? And that particularly, I'm thinking, do you market that to the bridges and structures people? Bill, do you get outside of the pavements area?
Oh, yes, certainly. We've done work for bridge deck investigations. We've got a couple of projects actually in the works coming up. We also do work for applications for subsurface utility engineering. And we've also had some emergency response work that we've done for Department of Water Resources for dam inspections. We've also done some work for the State Highway Preservation Office for particular sites that are in Caltrans that have archaeological significance. And we've also been involved every once in a while in some forensic investigations for crime scenes associated with the state highway network. We've had a couple of projects where we've had suspected clandestine burials that we've worked on, and we've done some projects working on looking at graveyards that extended onto Caltrans property and looking for grave sites that were within the right of way. So it's been kind of an interesting broad-based perspective on applications of ground penetrating radar for stuff outside of pavements as well.
Great, thank you. I'm going to move on to the third question to keep things moving. And I'll ask maybe Eob to start on this one. And that is, what are the biggest challenges you face to achieving higher agency adoption? For example, is it the program funding? Is it training? Or is it maintaining staff with expertise? Eob, do you have some thoughts on that?
Yeah, yes, I do. I think, like most of the folks here, we've been fortunate enough to work both on the research development part of technologies and also in the implementation side. And what I have seen in these years is that we put very much focus on the research development, but we put less focus on the implementation of technologies. And that is one of I think the main problem, because once you have to implement them, basically it's the DOTs or road authority that have to do it. And basically our engineers that have been doing other stuff, and this is a new stuff for them to do. You don't have that dedicated person like a PhD or a master that you would have in research development. So this creates a lot of challenges to the not enough confidence on this technology. And then you can break the challenges in different things. Like, for example, the cost. There are the known part of the cost of equipment, software licensing. Those are a little bit relatively easier. The unknown part is what kind of stuff you will need, what kind of qualification, how many staff, how many units of this equipment you will need, where would you put them? So those are some unknowns that create a little bit of not confidence in the technologies that I have seen in the past years. The other is also finding the proper application for this technology and knowing how are they going to be incorporated in the existing procedure that you have having. We have standard specifications based on other technologies. If you bring a new technology, what does it do to this standard? I mean, how are you going to work with them? How you're going to implement this technology? Can you scale this technology from one just testing one road? Can you take it to basically, can you include it in the workflow of the DOT? So those are questions that need to be investigated in a implementation side of it. And I feel like that's what we're trying to do in MINDAT through the program that I'm working on, the Road Doctor, through what Kyle does with the DPS and also the VETA program. Basically, we focus on how to best implement these technologies and incorporate them or adopt them in our existing testing procedures.
Great, thank you. Bill, do you have anything to add?
All of the above. So yeah, our perspective is slightly different in that we're pretty much out of the research phase and into the implementation phase. So now we have to kind of demonstrate results. So a lot of the challenges that we have is essentially training staff and letting them understand what the capabilities of the systems are, what it can, and especially what it can't do. Trying to make sure that we come into projects that people come in with realistic expectations for system performance, and that they understand that there are lot of great things that GPR can do, but there are also things that it can't do, and that you need to understand that as much as the pros going into your project, so that you have realistic expectations of what your final product is going to be. So we were. It's an interesting perspective from our side. Doing the kind of the outreach to people and getting them up to speed on what radar can do, and showing them what the results are for them.
Very good, thank you. While you're up on the stand, what is your prediction as to whether the agency will continue to increase the use of GPR? And if so, why?
It's increasing now. So we've had, I think year over year, we had a significant increase in demand for it. We're doing a lot more projects and larger projects. We've done within the past year, we've done single projects where we've collected 110 lane miles of radar data for predictive maintenance. Just yesterday, we collected 20 lane miles, which was about 20 minutes worth of work. So, but which was impressive for the people that were involved, that on the data management side of it, to see how quickly the data can actually be collected. But yeah, so from that perspective, we've seen a significant uptick in demand for the GPR service in California.
Great, thank you. Kyle, you want to add anything?
Sure, just quickly, I guess a couple factors lead me to believe that it's going to continue to increase. One of those being that there's simply improvement in technology with time. And we've observed that with the DPS, where the method itself of relating dielectric properties to what we care about, which is asphalt density, has been around since the 90s. It's just simply that the precision of and accuracy of the dielectric measurements and ability to collect them in a continuous nature has improved over time. And now it's at a point where we can actually start to use it to help contractors make construction decisions and improve their process. And that brings me to the second reason, in that there's other technologies that are complementary in how they interact with GPR, and that's in many different fields. But just one specific example that I've found with the current project we're working on with the density profiling systems is it's really enhanced when you have a full coverage dielectric map, when you can compare it with a thermal profile, and you can compare it with your information from your intelligent compaction roller counts and stiffness values and all those things. It tells a full picture about what's going on in the pavement that just wouldn't be available if we were still relying just on spot checks like coring.
Great, thank you.
Mike, if you will, just one
yes.
point. I think there is a key in that. The key is, as long as you build confidence with your engineers, the technology grows up. So in our example, since in the last 5 years, we've been reaching out to all our district engineers, material soil engineers, trying to tell them about the capabilities. The first year, they were a little bit resistant, but then in the last 4 years, we've been increasing the amount of projects that we are being involved, almost doubling at every year. So right now, for example, in 4 years, we have like more than 100 miles of road evaluated using the 3D GPR, over 50 projects for project scoping efforts. So what we see is it increase. But at the same time, not only the use of GPR is increasing, but I feel like it's also increasing the application of GPR, right? For example, we are using it for density, for thicknesses. Hopefully, we will be also using it for stripping, for other, to automatically detect stripping. We're working with Jacob and Paul for the moisture study. So I think the more application we find for the GPR, the more people will trust it, and they will try find way to incorporate it in their practices.
Great, thank you. So let me move forward. And Eab, since you're on the floor, what are some of the typical issues you encounter during field data collection?
Our program has different technologies. Not only the 3D GPR has LiDAR, video from road scanners. So With particular for the 3D GPR enduring data collection, we've been, I mean, every project we've been removing some of the challenges. We've been working on refining those testing procedure. So I feel like we are at this level. We are very comfortable with tuning the technology for our specific project. So data collection wise, we don't have that much problem. The only problem is when we are testing on very crowded bridge or very highly trafficked roads, we need to find when is the best time to collect data, or do we need traffic control? Those are the issues, but data collection wise on the 3D GPR, we have not seen.
Very good, thank you. And for the audience, we have another question on the view for you to respond to, so we can get a sense for how much GPR is actually being used. Bill, do you have anything to add to the typical issues that you encounter during field data collection?
The only significant issue that we really have is a coordination for lane closure and safety support. We have some specific regulations and rules that we have to adhere to when we're doing work that gets us slightly below the speed limit on the highway. And since we are focused on data quality, we actually end up driving slightly slower than the speed limit. So oftentimes we need to have some additional maintenance support for moving closure. And sometimes we even have California Highway Patrol support just to try to keep people sane on the roadway. So typically we're collecting data at around 50 miles an hour, which usually isn't a problem until we get on the interstate portions of the highway network where speed limits are 65, 70 miles an hour. In that case, since we have traffic coming up onto us at a fairly high differential speed, we need to have barrier vehicle support behind us, and we have to coordinate with our maintenance groups, and occasionally we have to have contract traffic control support to make sure that we have the appropriate safety vehicles behind us, so that the traveling public is aware that you have a slightly slower speed vehicle ahead of you and that you need to move out of the way for it and make sure that you're passing safely.
Great, thank you. While you're up, what are any challenges you have that limit your ability to analyze the data?
Yep. The biggest challenge will always be the sheer volume of data that we collect. So there are a great number of automated processes that are available, but there's still a significant amount of manual data interpretation, data culling, quality control analysis, and things that have to be done that require an interactive user. And so that will always be the challenge. And so the issue constantly that we face is trying to get the analysis hours per lane mile down so that we maintain cost effectiveness. And so there are a number of tricks up our sleeve that we can do during data processing that we can apply. But that I would say is probably the number one factor that we're constantly having to pay attention to.
Great, thank you. Eob or Kyle, any response on the data analysis challenges?
Kyle, I have one, but Kyle, do you have one?
You can start. Yeah.
Yeah. So I think what I see is a challenge is not data processing wise, at least for what we're doing for project scoping effort. What I see, one of the limitation is the reporting side of it. So with the reporting, I mean, we do report. We have created templates for reporting what the engineers need for that specific projects. But it will be nice to be able to share a lot more than just that. So I know Road Doctor software and the Examiner, you guys have the viewer that people have to upload in their computer and everything, but sometimes that is asking too much. So sometimes what we do, if we want to show them all the data, how it looks like, is basically we create YouTube video and send it to them. I hope in the future, if there are ways to basically create shape files and put them directly in a ArcGIS map or ArcGIS map or something like that. So people, instead of having just tables, they can also look, have visual result of what is going on in their payment and find a way to incorporate it with, I've seen you guys have included shape files now so that people can use also the reference points and everything. That's a very good progress in that view. Yeah, so I think the work needs to be done is more on the reporting side and enabling people to look at the data, the whole data, have a sense of what is they are looking for.
Great, thank you. Kyle, do you have a short answer for this one?
Yeah, just quickly, I guess the two factors I would focus on here are turning the data into information in a way that is suitable to the people who need that information. So for me, just two quick examples would be one, packaging your real-time analysis to the point where it's simplified enough where it could be something as simple as saying to a technician out there who doesn't know anything about GPR, who's pushing the cart, if that squiggly line drops, that's probably an indication that you're getting lower density there. And that's been proven to be a successful way just because of the timeliness, not necessarily the comprehensiveness, but then also having tools in place where, like Eob said, you are looking at the comprehensive picture, because by simplifying things, you're by definition eliminating useful information. So we also have to be able to have tools to look at stuff from a more comprehensive point of view too, that might be less timely.
Great, thank you. And Kyle, while you're on then, this is a very important question as we move into the questions for the manufacturers. What are the most important items you would like the GPR manufacturers to improve?
Mm-hmm. Well, first of all, before we get into improving, I have to give a compliment to the manufacturers. I think that hosting things like this, where you see manufacturers talking to each other and sharing information, I think is a really good thing to see from my perspective. I can say from our pooled fund effort focusing on use of GPR for density profiling, it's been great to see multiple vendors show up at our different meetings. And I think continuing or even further improving on how industry and GPR manufacturers work together to try to kind of grow the pie in terms of making GPR something that is used more widespread. I think that is potentially a good strategy for everyone to sell more equipment, which is obviously what the manufacturers are trying to do. But then from my perspective, getting good, useful results, it really does depend on that type of collaboration. So I would just say more events like this, and then kind of working together to identify and find solutions for the current barriers to adoption of the technologies.
Great, thank you. Bill, would you like to add some things?
Beg your pardon, I was on mute. So I think in terms of the GPR technology itself, over the years, I've seen significant improvements in the hardware and the software side. There are a number of things that the manufacturers have brought forth that I think have been monumentally effective in making GPR cost effective for routine use. I think one of the biggest challenges we're seeing, and it's going to be one going forward, has been there's a lot of RF noise, radio frequency noise out there that we're constantly having to try to overcome or trying to work around. And so I think RF noise suppression is going to be an issue that we're always going to have to deal with. We're going to have to try to figure out, are there any novel approaches that we can use to try to improve quality of radar data in the presence of numerous noise sources that are adjacent to the highways, cell phone towers, individual cell phones, radios, all these things that are contributing to the RF pollution out there that makes it difficult to acquire GPR data under certain specific circumstances. On the software side, there's always going to be trying to find ways to develop efficiencies. And I think the manufacturers and software developers have come up with some pretty good solutions for that so far. Some of those have been the automated reporting techniques, and some of those have been the auto picking routines that have been improving over time. And so those are going to be things that we're going to be continually looking at and trying to see what we can do, or what we think can be done to work with the manufacturers to see if we can get some kind of end products that are going to be more useful for the end users.
Great, thank you. Ehab, I'll give you a chance to maybe put in one or two
Yeah,
items.
just two things. I think with the GPR technologies, they have improved a lot. I think what is missing, we need to put more emphasis, is work more on the implementation side, understanding how this technology falls in the workflow of the existing procedure. To do that, we need standards, specification, but also we need also to understand how the GPR is going to be included with other data fusion with other technologies, FWD, TSD, coring, all those things, because that will give a greater, bigger picture of the payment situation, and people will have more use of it, in my view.
Very good, thank you. For the audience, we're going to move away from the panel discussion with the agency representatives at this time. We're going to move into discussion with the GPR manufacturers. And as we do that, I want you to begin thinking about the questions that you may want to ask of this panel. And I also ask that you kind of keep them at a higher cloud level, as opposed to I have a particular problem on a particular pavement. So let's try to keep them at the program level as opposed to the project level. So let me get into some questions for the manufacturers. Bryce, I'd like to start with you. What are the two most frequently asked questions or misconceptions that you hear from your clients?
Yes, thanks, Mike. One of the biggest hurdles is trying to align what their goal is with the technology with what the technology can do. A lot of individuals think GPR is a technology that can do everything, but there's specific applications for it. So understanding what that application you're trying to achieve is and aligning those needs is very important. Secondly, GPR is a tool that can identify anomalies or irregularities very well, but it's not a perfect science on telling you if it's moisture or what it is. So understanding what it can do and where you're going to use it is very important.
Great, thank you. Jacopo, do you have anything to add?
I agree very much with Bryce. I have to say that, you know, the FAQs change a lot depending on the pool of people asking them. We have very different kind of people that purchase GPR nowadays. You have people that is very experienced, you have people that is less experienced. So there is not really a very well-defined FAQ in a way. But most often you end up in capabilities of the system. So a little bit what Bryce was saying, you know, it's what can you do for this application? What can you do to find these kind of things? And I think the difficulty and the challenges is in isolating a certain feature, because as also Bryce was highlighting, we can detect things. The GPR by itself is not really telling you this is this and this is that. Is an interpretative job very often, especially when you're trying to characterize some certain characteristics, for example, in pavement, right? And so you know the thing is detectable, but then you need to put it in context. So perhaps that's one of the difficult part. You need to contextualize the data a lot. You need to put your own expertise in the data, and you need to trust the system in which it's detecting things. So you need to recognize them. Then there are maybe some misconceptions, questions that can lead to misconceptions related to capabilities of the system. For example, the depth of penetration, which is not constant. It depends on the material. So and this because GPR is not a mechanic thing. It is an undestructive technology. It scans the underground using electromagnetic waves, and these penetrate less, penetrate more, respond in a certain way in certain environments, and in other ways in other environments. So it's very difficult to put a very well defined, to case it very well and say you're always going to have 2 meters of penetration. You're always going to detect this kind of item. You're always going to do this, and you're always going to do that. So again, you go back to contextualizing the data a little bit and understand how the technology is responding to the medium that you're scanning.
Very good. Jacopo, while you're up then, how do you see the GPR system changing in the next 5 years? And what part of
Yes.
the GPR system needs to advance to increase that client use?
So personally, I think that advancements will be more software related. So of course there will be advancement in hardware, but I think that the ones that will be more tangible by the audience, by the buyers, by the users, are related to software capabilities. So a software that is able to tackle a little bit what Eyab, Kyle, and Bill were saying. So those tasks which are repetitive, for example, the interpretative tasks, the having to analyze a lot of data. Bill was saying, we are getting more jobs, which means more data, which means more time that you need to spend on them. So what we have to do, I think our duty right now is to provide tools that don't make you bored and make mistakes in the long term while looking at the data. You need to interpret them quickly. You need to have a standard way to look at the data, and the thing needs to be repeatable, and it needs to go towards a goal, which is not the radar data, is actually a report. And that's what Kyle was saying. I want to have information, not data. And therefore, I think that's where we are going to work the most, and that's where the advancements will be more tangible. Yes.
Great, Bryce. Any additions to that?
I agree with Jacopo on those. I think the technology is there. We can successfully use it now to identify what we're trying to achieve. But I think where it's going to make some advancements here in the next few years is more on the logistics and application side in the field, putting these technologies in places that they haven't been before, logistically, automation to putting them in the procedures correctly in the most efficient manner to collect that data accurately. So I think there's going to be big logistic changes in procedures and ways to implement this technology that's not as big of a pain for the person collecting the data. And that's one thing I'd like to add, and Kyle has been kind of the one to promote this. If you are going to invest in GPR, having a champion, a person that wants to be in charge of the technology, learning about it, taking the data, collecting it, and really driving it, helps everybody succeed, especially the implementer. So.
Very good, thank you. While you're up, Bryce, just a very quick question, maybe a couple of features of what should an agency or a consultant list in their contract features if they're requesting a quote for purchasing a GPR system?
Yeah, so, I mean, one of the biggest things is what are you trying to achieve? What's your end goal with the technology? And then from there, we can kind of align what tool might be the best for you. Other key features that we're looking for are, obviously the geology that you're working in, as Jacopo was talking, the geology of what you're using, where you're using the radar is going to affect your data, your depth, all those types of things, your logistics. Do you have to collect it at highway speeds, or is this something you can collect with closed traffic? Are you trying to use this technology proactively, or using it for forensic or design? Those types of that type of data really helps us align the right technology to the application.
Great, thank you. Jacopo, anything to add there?
I'm pretty much on the same page. I think the most important thing is to understand what kind of system you should be using, given what you want to detect. So, you should start from, can I actually use a GPR system for this, or should I be using something else? And then you step into the world of GPR. If the answer is yes, then, you should be using a GPR. Is understanding which GPR you should be using actually, and what advantages does it bring you. Which does include software, and the inclusion into other together with other sensors, how much you can include that kind of system into your workflow. So and also, you should factor in how long it's going to take you for learning it, and understand that that is a procedure also, because it's not only limited to using a piece of hardware, you also need to interpret the data. So that's something that needs to be factored in. And I mean, we as manufacturer, we can provide training. We are there for users as much as we can. And GSSI the same. I know they do fantastic training courses, for example. And then learn from others. Yeah, because and also that's what Bryce was saying before, find the champion, find people that is doing that, and then look at what they are doing, because you're going to learn from them. And if you trace it back to the application, then you find what problems people have already stumbled upon. So
Very good, thank you. Well, I want to thank all the panelists. You're taking up your time today to essentially share your experience with GPR. We're going to move into the questions from the audience, and a number of them are quite detailed. I'm going to kind of scroll around and find a few that I think would be of interest to a number of people. And one of the questions is, what are some of the things GPR can't do? And this kind of follows up with your comments about making sure that you essentially align the right system for the right applications. Panelists, anyone want to jump in and talk about some probably scary situations where obviously the GPR did not perform for what you wanted to do?
Yeah, I think I can kick it off. I think one of the things that's been the most challenging was the clandestine burial work that we'd been asked to do. It's been that proven to be extremely difficult to do, and we ended up doing some research in it, and just discovering that basically once a human body is buried, decomposition occurs very rapidly, to the point where within about a year or so, if you haven't gone out there and tried to do a radar survey on it, the odds of you discovering a clandestine burial drop significantly. And so we'd been asked at times to go and look at burial sites that are 30, 40, 60 years old, and just you're not really going to have very good probability of finding that. And so we do it anyway, because we're trying to give the family and survivors closure on they've lost a loved one to a horrific crime, and we're trying to help them out any way we can. But that was a big challenge, and some of the most heartbreaking stuff we've ever had to work on.
Anyone else?
I think it's difficult to top that, but I think from our perspective is also not the use, but is it efficient? What is efficient to use? For example, we are called a lot of times to check sinkholes under the concrete or something buried, and most of the times we work closely with our geotech group, with our geotech group. They have ground couple GSSI, and we go along with 3D GPR and the ground couple one antenna, one channel. So is it efficient to bring the entire van there, or is it, what is the best? So I think that's something we not necessarily wish GPR does the job work good, but having to collect data in longitudinal and then transversal areas and everything. So it's also good to know what is efficient, which antenna to use for certain aspect. So.
Very good. Let me move on. This question specifically is for Kyle and Eob. Since you are in a colder climate, is there any indication of a potential to identify frost heaves with your GPR data sets?
Well, I would just say, what I've done on that subject matter is not as recent or comprehensive as EOB, so I'll pass it on to EOB to answer that one.
In a way, yeah, that's a good point for cold climate. We have problem with cold climate frost, and we have a spring load restriction. So we've been investigating the use of the GPR if we can monitor the level of moisture or during spring thaw. So we've done almost 2-year study using the GSSI GPR ground couple antenna and on the on-control fixed field experiment in Mill Road. And we saw very promising result that the GPR can be correlated with the moisture level in the pavement. It tells you, it indicates you when the frost start to thaw. So we saw very good indication using the GSSI antenna. Now we're working again with 3D radar to see if we can replicate the same study with the 3D GPR. And the advantages are you can measure continuously on a pavement. You don't have to use the FWD basically without as a continuous testing. You can have full coverage. Yes, we do see very promising result in that sense. But we've done this in a field controlled experiment where we know the structure, where we know the thickness of all the layers. We're trying to see if this can be implemented on real road. We have hired the AET, a local consultant, to collect data on real roads, and then we will see how that is, if that can be implemented on real roads. We've been doing this on instrumented test cells. We want to see if this can be applied on real roads too. We have some published paper on that if you are interested.
Very good. Let me, let's see if there's a question here. Here's a general question. What is the minimum depth of penetration with GPR for asphalt paving, for asphalt pavements? Jacopo, would you like to jump in on that one?
Perhaps it goes well with what I was saying before. You cannot really say, but well, I seen the minimum, meaning how little can you penetrate, I guess.
Yeah, what is
Because
the maximum depth?
is, if it goes well, is meters, 2-3 meters. If it goes really well, even more. But if you have to stay, what's the worst that I've seen? I think I was in China somewhere, and there was a very, very conductive type of concrete that they use for roads, and we could just penetrate the asphalt. Then when the signal hit this concrete, it was dissipated. So you had a bigger reflection there, which was very nice and made the asphalt layer very clean to trace. But then very, very little more than that. So we are talking 15 to 20 centimeters, perhaps. So there's no limit to the minimum. If you pass on top of something that is incredibly conductive, you cannot penetrate it. That's it.
My interpretation of the question was, what's the minimum thickness before the interference from the surface arrival is going to interfere with the bottom of the layer? So that is to say, for an air-coupled antenna,
okay, what is the minimum thickness you can detect? Yeah.
Could you speak about that a little bit?
Yeah, actually, again, it can vary a little bit depending, but I would say that with an air coupled system decently elevated from the ground, and with the recent, more recent processing, let's say, you can detect down to centimeters. You're able basically to shave off the surface from the data, and you remain with a very clean, very shallow asphalt layer. Then it depends. It goes down also to evaluating what is the time to depth conversion. So that's the other matter, because we measure time. That's the raw data for GPR, is not depth, is not meters or centimeters. But yes, you stay on the centimeters level. Let's say 0 to 5. 2 to 5 centimeters, so 1 inch to 2 inches.
If I may add to that, Jacopo, I think the study that we've been doing, we've been collecting on Mill Road cells like for almost more than 2 years now, every month, and during March every week. And what we've seen is exactly what you're saying. Is we've been collecting on different type of payment, different structures. We see that the way that the signal propagates in these layers, it depends not only from the payment structure, but also from when you collect it. So sometimes you can have a larger penetration depending on the moisture condition, on the frost condition of the pavement. Sometimes when it's dry. So it really is very important for you to understand, first of all, your antenna, what is the signal, how it propagates, what is the frequency, and everything, and then but also understand your payment, the payment structure, the condition of the payment structure. So that's the thing that we did was very nice in the sense that we collected on all type of payment structures at different times. You see that changes very significantly, not significantly, but and that the change in signal propagation, that's the approach we use to determine, to measure the level, to monitor the moisture condition. So
Very good. I'm going to maybe start with Bryce with this next question, and I'm basically absorbing a few of the questions together. And I know I've had a number of comments within the Kontur team about what exactly is the quality or accuracy of any thickness or of any depth determination that we get from a ground penetrating radar response. Do you want to talk about that a little bit as to, am I doing it to 1/10 of an inch? Am I doing it to an inch? What is the norm?
Yeah, and again, that depends on the tool you're using, but typically we can see 1/4 of an inch accuracy with a system like the road scan, which is an air coupled system. And a lot of that will depend too on how the data was collected, the geology and the design of what you're collecting through. But that's pretty common, right around that range. The speed, there's a lot of variables that go into the accuracy of that, but that's a pretty safe, common number right there.
Jacopo, would you like to add?
No, I think that was fairly comprehensive for what I don't think I have much to add to that.
And I'll add a little bit from a recent project I was working on, and I think this is important for everyone to understand. The deeper you go into that pavement structure, the lower the frequency is that is actually giving you the most response. So as you go deeper into that pavement structure, the actual quality or accuracy of that thickness changes, where we might be able to get to, let's say, a 1/4 inch or a 1/2 inch on the asphalt itself. If we're talking about the depth to the subgrade, that variation plus or minus is probably going to go up just because of the data that we're working with. Bryce, would you consider that a fair observation?
Yep, exactly. I mean, you have to take into consideration too what is the asphalt layer, or what's underneath the asphalt layer. As far as, is it concrete, is it aggregate base, is it another asphalt layer that's got similarity in dielectric values? So but you're absolutely right with the accuracy, with the depth, and hit it right on the head there.
Very good.
I think you need also to consider the pavement layer condition. If it's old, if it's deteriorated, if it's stripped, then how you're measuring the accuracy based on what? If you have a pavement which is stripped, you're not basically extracting the entire coal. So, but that is a key question that we need to address because people care about the accuracy and precision.
I want to put this to Bryce and Jacopo. Outside of the US, is there a user group, a user producer group for GPR in Europe or in Asia?
In a user group, we have different user groups in different countries. I know there is one in China, there is one in Japan. Using of users of our system. I don't know if there exists a generic GPR user groups. I think that, you know, normally these things pop up often during the years, and they are born and then they might die, or, you know, somebody needs to take responsibility for it and nobody really has time. So that's that's a story that repeats itself. But I don't know if there is a generic user group, like a GPR user group, specific to pavement also, because it should be specific, application specific. Otherwise, it just is too wide. I don't know if there exists one.
All right, so I have another.
Maybe the only thing I can add is that in Europe there is the GPR association that one can have a look into, and we are part of it. Other manufacturers are part of it. So it's and some users are part of it. So that could be something to look into if you are in Europe.
Very good. I'm going to open this question up as well. Each of you have some different experiences here, and this is relevant to what is the most favorable way to collect with a vehicle-based system. And I think the question is, should this GPR be in the front of the vehicle, behind the vehicle? Is it on a trailer? What is everybody's own thoughts on what's the best way to mount the system on a vehicle for vehicle type surveys?
I think I can speak for both the ground coupled and the air launch community, and the answer is going to be it depends on what you're trying to accomplish. We do both. We have an air launch system that is mounted on the front of the vehicle, and we have the capability to use a ground coupled system that is mounted on a trailer that is towed behind the vehicle. Each one of them have their benefits and their pros and their cons. Typically with the trailer, you're going to be limited to slower travel speeds, slower acquisition speeds, depending upon how well your trailer is designed, or whether what you have is a trailer that is that's roadworthy or DOT certified. Anytime you have an air launch system, you're going to be able to collect data faster, but you're going to sacrifice depth of penetration under most normal circumstances. But you're going to collect a lot more data. So it just depends upon what you are trying to accomplish with your surveys. And so we will use both systems depending upon what our data needs are. And so anytime that we're using our trailer system, we generally have to have traffic control. We generally have to have a static lane closure, and we have to occupy a lane. If we're using an air launch system, we don't have to. We'll have a barrier vehicle that will support us just to maintain traffic. But that's the extent of it with an air launch system. So each one of them has their pluses and minuses.
Great, thank you, Bill. With that, I'm going to go into some closing remarks. We're about to complete our hour. I want to first thank all of our panel members for sharing their time and experience. We have one final audience question, which is relevant to how useful was this roundtable, and would you attend another one? I also want to thank the audience for your active participation in the surveys and in sending in questions. And as I mentioned earlier, we'll try to get some responses to your questions back to you. Based on the success of this roundtable, I anticipate that we would have a regular series of roundtables on topics as they emerge and on common topics that come up. I know there's a list of technical topics that need to be discussed, at least from my own mind. If you would, in the chat box as the audience, if you think a different format for this roundtable would be better. You know, right now we have a agency and manufacturer set of panels, and we went through a series of questions. If you think another format might be better, that please share that. And also within the chat box, if you would add any particular topics that you think would be of benefit for a future roundtable, so we can start to get a sense of the most important questions for the agency and industry ground penetrating radar users. And let's see, with that, if there are nothing else for us to talk about, I do want to thank everyone for jumping in and attending and participating in this roundtable. We'll give you some time to get some things into the chat box before we close things out. As we close out this roundtable, then I want to go back and actually thank Kent Martin with Kontur for coordinating things and putting everything together. Things went fairly smooth today, and we hope that everyone will be interested in participating in some future roundtables. And with that, I'll ask each of the panelists, you've given me a 15-second overview of where you might see things going into the future. And we'll start with Bryce and work back towards the agency.
Yes, thanks, Mike. The future, I honestly think we're just at the tip of the iceberg with what this technology can do, especially as we start to implement it more efficiently, logistically into operations and see the benefits of it. Non-destructive testing has huge benefits, and I think a lot of people are just starting to find a lot of those benefits specifically for their industry. So the future is very bright, and I'm looking forward to it, being part of it.
Jacopo?
I can add that my vision for the future is to have more automatic tools, which doesn't mean that they are making the system necessarily stupider, but they are making it smarter without making it oversimplified in order to address tasks that are not worth the time of our users. So that's where I see the future.
Ehab?
I think the future is bright, especially because this technology have some significant. They have bigger coverage. They reduce the amount of corings and everything that is. They reduce the safety and cost concerns. They have, compared to the existing procedure, they have some advantages that I think they will. I see a bright future for this type of technologies.
Kyle?
I think just in addition to we've already touched on the coverage and the data fusion with other technologies and automation leading to a bright future. The only thing I would just add is that I think being able to geospatially map our results too, and the improvements with and availability of GPS capabilities suggests that there might be some applications that previous to these improvements start to take off now.
Great, thank you. And Bill, we started with you and we'll end with you.
Oh, great. So I think it's the technology has come a long way, and I think there's still going to be improvements that are made both on the hardware and on the software sides, specifically in terms of use of machine learning for some of the analytic tasks. I think will go a long way towards aiding and cutting down some of the processing time in terms of doing predictive layer picking and improving some of the quality control aspects of the data processing. And data visualization is always going to be something that's going to be key, because most of our end users are not going to be necessarily ground penetrating radar experts. So what they want to see is they want to see very simple presentations that tell you, where is it good on my bridge deck? Where is it bad on my bridge deck? Where is my pavement good? Where is my pavement bad? And so things like that towards data presentation, data visualization are going to go a long way towards improving the efficacy of the technology. So I think there's, the future definitely looks bright for it, and I can see it going, doing. I'm at a loss for words on trying to figure out exactly where it might be headed, but I think, yeah, the future is definitely bright, and I think there are many things that can be done and are actually waiting out there in the wings for us in terms of where the technology is going and what it's going to be able to provide for us, for our projects and for our engineering and for our inspection and maintenance of both our state highway network, looking for underground utilities, all kinds of applications for the technologies.
Great, thank you, Bill. For the audience, I know that you will receive some type of an email back from Kent regarding the ability to review again this roundtable. So look for that in your emails. And with that, let's go ahead and close this roundtable. Everyone have a good week and a good weekend coming up. And best of luck and stay safe out on the roadways. Thank you.
Thank you.
Great.
Thanks,
Thank
Mike.
you.
Thank you, everyone.
Thank you.
Thank you, everyone.
Have a great day, everybody.